Hi there. Welcome to episode 3 of our closed-loop automation demo series. In episode 1, Shiv had demonstrated closed-loop automation for deterministic design and install of a wired and wireless network to build a strong foundation. In episode 2, Deepen had shown us how the Nile Access Service automatically resolved wireless coverage issues due to external factors. In this episode, my colleague Karthik will demonstrate how the Nile Access Service automatically performs root cause analysis when it comes to deviations in service quality within the wired network. Before we see this in action, a quick reminder. Here at Nile, we treat enterprise networks as a service, not a product. This approach allows for faster innovation thanks to an agile cloud software development model. Closed-loop automation capabilities powered by AI help scale deployments, while significantly reducing the ongoing operational expense. An integrated data model across the technology stack, coupled with environmental context, allows for real-time observability and continuous optimization of the service performance towards delivering industry's first service-level guarantees for coverage, capacity, and availability. Our technology demos in this series aim to show how we proactively address deviations in service quality before they cause significant downtime for your users and critical applications. In this demo, instead of countless number of hours spent on manual troubleshooting involving packet captures, monitoring of log files, cable tests, and many others, we will show you how the root cause analysis within the wired network can be fully automated. As opposed to simply exchanging hardware in the hopes of resolving network performance issues, identifying the true source of the problem also helps eliminate costly replacement and returns. Now let's hand it over to Karthik to give us more details. Take it away, Karthik.
In this example, we will see how Nile automatically alters the network behavior to work around link failures without the user or the administrators knowing about it. First, Nile Services Cloud creates a digital twin of the topology after the successful completion of the installation process. Smart agents deployed in Nile network elements continuously collect the telemetry data. They stream the collected data to Nile Services Cloud. The collected data includes process information, system information, protocol information, etc. This telemetry data hydrates the digital twin. It updates the various attributes of the digital twin, such as the interface, CPU, memory, etc. The models in our cognitive decision capabilities look for anomalies in the collected data. They first analyze the historical data. They then predict the future threshold values. If the latest values do not meet the expected threshold, then the data is considered an anomaly. The models are intelligent enough to take into consideration of various contextual factors such as seasonality, number of connected devices, their traffic, etc. In this example, cognitive decisions detected an anomaly in one of the links. They updated the link in the digital twin to reflect the anomalies. After that, they updated the cost of the links to the maximum possible value. This update causes routing protocols to recalculate the routes. After the recalculation, the route table of the network elements is updated. The traffic is automatically rerouted around the faulty link. All of this information is captured as alerts in Nile Autopilot. Cognitive decisions also automatically create a work order to fix the link with CRC errors. They also make customers aware of the issue. After the successful completion of the work order, they update the digital twin to reflect the corrected link. The entire closed-loop automation happens without the IT administrators or their users knowing about it. This means the users can continue their Zoom sessions without having to worry about the network. Now let's go to the demo. This is the Nile Autopilot application that shows a CRC error incident that happened at one of our customers. This is the digital twin of their network. There are several sensors, access points, access switches, distribution switches, and headends. This is the active headend. The digital twin is continuously hydrated by the telemetry data received from the network. The telemetry data corresponding to this incident comes from the interfaces minutes data source. The in CRC error data source contains the actual CRC error data. In this incident, the link between the distribution switch 65674 and the access switch 65988 has CRC errors. The dynamic threshold-based anomaly detection capability in the cognitive decisions module in Nile Services Cloud detects an unusual spike in the CRC errors of the link connecting the switches 65674 and 65988. It immediately raises an alert, which is what we are seeing here. The alert contains all the useful information such as name of the customer, the location, the switch identification, that is the serial number, the severity of the alert, and the time at which the incident occurred. The cognitive decisions module sets the OSPF cost of the link to the maximum possible value. This triggers a routing protocol reconvergence. After successful convergence, the forwarding table is updated. The traffic is routed around the failures. Later, after the incident is addressed either by replacing the cables or by some other means, the cognitive decisions module sets the OSPF cost back to its original value, thereby restoring the behavior of the network. The detection of the spike in CRC errors, changing the OSPF cost, and restoring the network's behavior to its original state achieves the closed-loop automation. All this happens in the background without the user or the IT administrators knowing about it.
Hey, Karthik, much appreciated. Thank you for this demonstration, and thank you for tuning in. As you can tell, we are radically reducing the amount of time it takes to detect and resolve potential performance issues within the wired network. Hope you found it relevant to your environment. We are looking forward to continuing the conversation at nilesecure.com. In the meantime, be sure to check out the other episodes in our demo series, highlighting how the Nile Access Service utilizes closed-loop automation powered by AI to tackle, design, and install operations, wireless coverage issues, software bug fixes, and system software upgrades.